Hi, my name is Nan Cohen. I had the wonderful opportunity to participate at the Spirit, Commerce, and Sustainability Conference, which was held here in Missoula, Montana, during the weekend of September 22nd, 23rd, and 24th. Rick Gold and I were members of the film crew. There were many people responsible for bringing the conference to us, including Caring for Creation Network and Women's Voices for the Earth. I'd like to thank everyone responsible for the conference. It was a wonderful event. Now we have for you Janine Benyus' Keynote Address. Janine is the author of the book entitled Biomimicry. She is a very gifted scientist and has a wonderful heart.
Introducing to you one of my nearest and dearest friends, although these days she's in such great demand all over the country and all over the world that I rarely get to see her or spend any time with her, which is a great sadness to me. So we're going to have to do something about the sustainability issue, Janine. When I was thinking about how to introduce Janine, I kept thinking about that song from The Sound of Music that the nuns sang when Maria decided to get married. That song about, what are we going to do about the girl called Maria? Do you remember that? Because they were just perplexed by this wonderful woman who was so full of energy, who didn't quite fit in with the rest of the nuns, but she didn't quite fit into the job she had been sent to do. And so she was a mystery to many people. And I keep thinking about that song because I keep thinking about Janine, because she has such a wonderful quality. I think about Janine talking about sustainability and all her great ideas and how she makes biology become so alive. But the fun thing about her is that she herself is sort of like solar energy. She's got this electricness about her and this enthusiasm about the work that she's doing. And if you are lucky enough to get into a one-on-one conversation with her, you will see that incredible sparkle in her eyes about this work. And I think that's what makes her so extraordinarily successful in the work that she's doing. I wish I brought my glasses because I can hardly read this program. But Janine is a life science writer and author of 6 books, including her latest book, Biomimicry, Innovation Inspired by Nature. In Biomimicry, she names an emergency science, it's that too, an emerging science that seeks sustainable solutions by mimicking nature's designs and processes. For example, solar cells that mimic leaves, agriculture that looks like a prairie, businesses that run like a redwood forest. Janine's other titles include an animal behavior guide called Beastly Behaviors, and 3 ecosystem field guides. And I won't go to the titles, they're in your program book. Janine is a graduate of Rutgers University in New Jersey with degrees in forestry and writing. She has worked as a backpacking guide and as a translator for science speak at several research labs. She now writes science books, teaches interpretive writing, and lectures at the University of Montana, and works towards restoring and protecting wildlands. She's an educator at heart and believes that the better people understand the genius of the natural world, the more they will want to protect it. And the exciting thing, some of you were lucky enough to go to her workshop this weekend, and we got and she worked that with Dana Baumeister here, and we got such enthusiasm from that workshop that we're going to, as I said last night, try to get that happening so we can do a full 2-day workshop here in Montana. But the extraordinary thing is that Janine is going and talking to major corporations around the world and the people that need to hear this. She's getting into the doors that some of us only dream about getting into. And I want to tell a few stories about Janine. I first met her 12 years ago, I think it was at least 12 years ago, at a barn raising down the Bitterroot. And I was really taken with her energy and her warmth, and that's sort of how our friendship starts. And I was trying to drag some stories out of her family and close friends, and her father just told me a story about her, which I think is a wonderful story. It's not embarrassing, Janine. But Janine, when she was a teenager and in high school, worked as a naturalist at Mammoth State Park, and she was going to do she wanted to do what was it called? An orienteering class where folks would, find their way through the forest and to a lake and across this lake. And apparently she got quite nervous as time was coming out. She knew what she was doing, and this is Janine. Janine really knows what she's doing, but she's very modest, and so she doesn't always admit that. But anyway, she wanted to do this orienteering course. And so at the last minute, she rushed off to the library because she felt that she needed some added materials to do this. And she asked the librarian for some materials on orienteering. And she looked and looked and couldn't really find anything. And she said, well, let me give you a suggestion, young lady. Go over to Monmouth Park, and there's this young woman called Janine Benyus. And she knows everything there is to know on this subject, and she'll help you. So with that, I would like to introduce Janine Benyus. There's one other thing I'd like to say that I didn't say earlier that I think is really important to know is when we were organizing this conference, a lot of people locally who were part of our organizing committee didn't know about Janine and Janine's work. And that's why I'm so excited that she's here to talk about it, because she's nationally known. She's internationally known, but somehow in Montana she's remained a secret. So I'm really glad that we're going to break that veil of secrecy today. So you need to.
Thank you, Brian. I can't believe the orienteering story came out. How's that for circular thinking? God. Let me get this on here. Missoula is the land of the tremendous introductions. It's like being at your own eulogy. When hearing it it'll still do you some good. Thank you, Brian. This is a closing ceremony for this conference too, so I just want to thank the habitat creators of this conference, the people who put us under the same canopy, We have business leaders and spiritual leaders and civic leaders and idea hounds here, all under the same canopy. It's a necessary diversity, I think, right now, just in the nick of time. Evelyn Fox Keller is a writer who wrote about Barbara McClintock. Barbara McClintock is a Nobel Peace-winning scientist who looked at the corn genome and the necessary diversity in the corn genome. And Keller says about McClintock, she says that Barbara practices the highest form of love, which is intimacy that does not annihilate difference. And that's the kind of necessary diversity we need. And nature celebrates diversity and clamors for diversity. And you can see it right now. If you go out, it's fall in Montana, and winter is coming. And if you go through the woods this time, you'll see interspecies flocks, okay? So you'll see warblers and chickadees and nuthatches and woodpeckers, and they all get together, right? And they go through the woods together. They kind of they don't normally flock up together, but they do because winter's coming, and because the food sources are scattered in the forest. Think of those food sources as ideas. A certain bird on the edge of the flock will find a food source, something useful, and will call to the other birds and the other birds will rush over there. And this is how they find the scattered, useful things so that they can get ready for winter. Sort of like what we're up to right now, the necessary diversity. What I'd like to talk about today is expanding our flock, flocking up, not just with each other, but actually with other species that might help us to find those useful, nutritious ideas that we need right now. If I know anything, it's because I have had such great teachers. Look at where we live, right? I mean, every day I am taught by the organisms and the ecosystems that enliven these mountains. Back in, remember when it was so warm in February? We should have known the fires were coming. It was so warm that I was getting ready for a talk that I gave to electric utility executives, energy executives. And I was trying to figure out what to say. And I went outside on my new lawn chair, and it's the best piece of office equipment I've ever bought. Because what happens is, you know that great chair I have? You zip back in this chair, and it tilts you so far back you can't do any work. You can't really write, you can't really use your laptop, but you have to look up at the sky. So I'm trying to think. So sure enough, before I saw anything, I heard a sound. I heard a sound, not a noise, a sound, and there's a difference. And it was, anybody know what that is? No. No. I was looking in the sky. And it was, a little while later, I saw this form circling. And what it was a sandhill crane. Yeah, that's what they say, rook, rook, rook. 7-foot wingspan. The thing stands like the size of a toddler. They're huge, they're beautiful. And it was coming down, and what it means by rook, rook, rook is it's asking its flock mates, is there any food down there? And it's up about 2/3 of a mile straight up in the sky. These are long-distance migrators that go from the southern Americas all the way to the Arctic Circle to breed, okay? So they are way, way up there, and they're not going to come down unless they know that there's good feeding. So it let out this call that travels through that 2/3 of a mile of sky not because it has an amplifier that's plugged in like I do, but because it's got a windpipe that's shaped like a French horn, and it amplifies this beautiful woodwind sound, right? All the way down. Anyway, it was coming down at a diagonal towards me, because this is what they do. They fly very, very high, and then they'll come down at a diagonal. So it wasn't losing any forward momentum, really. I mean, it was still making ground as it came down to me. And because I didn't call back to it and say, yes, good feeding here, I didn't know its language, it decided to go back up. Now, again, it didn't stop and fuel up with jet fuel. Instead, it went over our pasture, and unbeknownst to me, there was an invisible thermal, like an elevator of warm air on that pasture. And it hit that elevator, and it circled straight back up, out of sight. Never once flapping. Why flap when you can soar? And that's what life does. I mean, life surfs for free. Life finds the free energy sources. And life uses information instead of energy. You know, it checked out the opportunities and the limits of its habitat. It tuned itself to that place, and it places itself in community. It asked its flock mate, is there good feeding there? It's also what we're about. It's really what we're about at this conference, I think. If I know anything, it's because I've had great teachers who are, including the people who live in the palm of this place and who open themselves to its teachings. Is Bill Kittredge here? Bill Kittredge, in his important book, Taking Care, has a line that I love. He says, What we need most urgently right now is a fresh dream of ourselves that will tell us how to act. A fresh dream of who we are that will tell us how to act. Boy, I think he's right. What we've talked about at this conference is the dreams that we've had of ourselves. Dreams like, the earth was put here for our use. The resources are here for our taking. They are limitless. The dream that we're at the pinnacle of creation. The dream, the tragic dream, that not only are we at the pinnacle of creation, but that we've graduated. And we are no longer nature. Nature's, and it's even in my book, you know, it's innovation inspired by nature, as if we are not nature. And I think that that's caused us a lot of pain, and it's caused the earth a lot of pain. It's allowed us to literally get away with murder. But I don't believe that we are not nature. As a biologist, here's my fresh dream. We are nature. Everything that we do, all of our strategies, all of our behaviors, all of our artifacts, our buildings, this podium, this nylon carpet, those lamps, our highway system, B-52 bombers, they are natural because we made them. The question is, are they well adapted to live on Earth over the long haul? That's the question. It's not yes or no technology. It's, are our artifacts and are our behaviors well adapted to live on Earth over the long haul? Because we're a very young species, right? I mean, if the age of the Earth was a calendar year, and this was December 31st, and the Big Bang was January 1st, we got here 15 minutes ago. And all of recorded history has blinked by in the last 60 seconds. And life bootstrapped itself up out of the chaos in March of that year. And life has learned to do amazing things. Everything we want to do. And even things we haven't thought of. The wood frog that freezes solid and thaws back to life with absolutely no harm to its cells. The hemlock with 16 million needles. And those needles tilt like level-lower blinds to get exactly the right amount of sunlight. Combs moisture out of the fog to feed itself water when it's dry. Bioluminescent algae that splash chemicals together to make light. Rhino horns that heal themselves when they have cracks, although they have no living cells in them. How do they do this? Leaves that not only pump water, keep themselves clean, exchange gases, breathe, but also harness the solar energy, lasso that energy down, the energy that fuels all life, including us. Not only does that, I mean, you thought you were busy. This is a leaf. Amazing. Gets chewed by an insect, sends out chemicals. I'm being grazed. Everybody beef up your defenses. I mean, it's an amazing thing. But what's most amazing about this leaf, and you'll find this in every single instance, the deep pattern, is this. The leaf, at the end of its useful life, it pumps back nutrients back to the tree. It turns a glorious golden color, maybe if it's aspen, falls down, and returns to the soil to create what? New trees. The next generation. It creates conditions conducive to life. And that's what life does. That's what life does in ensemble. You know, by eating and excreting and doing the things that life does naturally, it actually sweetens the earth, filters the water, filters the air, pollinates, builds soil. Life has learned how to create conditions conducive to life. Our biological elders, the ones who are here with us, 99% of all species that have been on Earth are extinct. Because they didn't learn how to do that one thing, which is create conditions conducive to life. And I think we can do that. I think we can figure that out. I think that's the design whether we're doing products or processes or policies. Do they create conditions conducive to life? Are they well adapted to life on Earth over the long haul? I think that's it. And it's like, well, how are we going to figure this out? We got to do it quick, and you get into that angst. The good news is that we don't have to do this alone. We have 30 to 100 million species that are models for us. And I wrote a book called Biomimicry. And what I did was I went around, I just asked the question, is anybody trying to consciously emulate nature? And once I asked that question, I found all kinds of people who are changing the paradigm from learning about that sandhill crane to learning from that sandhill crane. And I truly believe that the insights that they're discovering are going to guide us. I'd like to talk. The book is a book full of stories. So I just want to tell you 2 stories from the book. One is how nature makes things. And the other is how nature makes things disappear into networks, into communities. And the moral of both stories, there's this hidden likeness across all these fields. That's what's so beautiful. There's a unity in the diversity. The hidden likeness in these 2 stories is that structure, meaning how the parts communicate and cooperate with one another, how the parts are in relation to one another. Structure. Community structure grants function. And the function is creating conditions conducive to life. So that's the moral of these 2 stories. So how nature makes things. And this will give you an example of how biomimics are working. It's usually an us and them story, because biomimicry very much flips the paradigms. So I have to tell you about how we make materials first, and then I'll tell you about how other earthlings make materials, the ones who have been here a little longer. What we do when we make a material is we basically take a bulk material and we carve it down into what we want with a lot of waste left over. Our waste is about 96%, and it's about 4% product is what we get, is what we're doing right now in this country. And what we do to carve this bulk material down is we do what material scientists call heat, beat, and treat. They heat it up. For instance, when you make Kevlar, which is what's in our flak jackets, it's our strongest, toughest fiber. We take petroleum and we heat it up to 1400 degrees Fahrenheit in a vat of bubbling sulfuric acid, which comes in a bottle with a skull and crossbones on it. You've seen it. And it's very expensive to dispose of as well, to sequester. Anyway, we heat this up, and then we draw it out at enormous pressures, and we make this really strong and tough fiber that'll last for 20,000 years in a landfill, as well as stop bullets. Now, nature's making materials all the time, but nature makes them in a completely different way. Nature makes materials from the bottom up. Instead of carving something down from the top, nature templates for materials so that they actually self-assemble, so that nature gets exactly what she wants with nothing left over. It's design. It's information added to matter instead of energy. It's design. It's structure. So, for instance, a spider takes, and here's the other thing. Here's the condition that's needed. A spider manufactures in its own body, so it can't afford to do the heat, beat, and treat thing. What if we had to live in our manufacturing plants? What if we had to sleep there? Right? Okay, so a spider takes flies and crickets at one end. This is the manufacturing flow chart. Flies and crickets at one end, right? Breaks those down into molecules, and then in water, at room temperature, in the abdomen, templates at the DNA level, brings those molecules back together into proteins. The proteins are three-dimensional molecules. Think of those on a Nova show, three-dimensional molecules. Because of the way, and each has electric personality and a shape, that is absolutely specific so that it falls together through physics, self-assembles into a liquid crystal, and then it's squeezed out through the spinneret, one of 6 on the bottom of the abdomen. Each spinneret has a different quality of silk that comes out. It's amazing. Squeezes it out, and what comes out is a biodegradable fiber that is 5 times stronger ounce for ounce than steel. Silent manufacturing process in water at room temperature. Materials science engineers are envious of this. And they are meeting in rooms like this by the thousands to not to farm spiders, but to figure out how to make fiber in a new way. It's getting too expensive and hazardous to do it in the old ways, and they see that coming. So when I talk to electric utility executives, I say, you may not need to run wires to factories in the future. It may be self-assembly. Let me give you another example. You say, okay, well, that's great, that's fiber, it's soft stuff. Nature does things with soft stuff. Nature also has hard materials, bone and shell. You ever wonder how a shell forms? You know abalone, people dive for abalone and they eat the meat, and the inside of that shell is that beautiful mother of pearl, you know, that iridescent stuff. What that is actually layers of calcium carbonate, of chalk, okay, which is a mineral, which is not a very hard mineral, right? But in between those layers is this squishy polymer, a protein that the abalone lays down. So that when an otter is taking a rock and breaking it onto the shell, instead of cracking, it actually slides on the polymer. It's this beautiful structure, this laminated structure. But what's really interesting is that the abalone doesn't take a trowel and, you know, make bricks and put mortar between them. It doesn't make it that way. It excretes proteins from its body into the seawater, and a lattice structure self-assembles. The protein actually self-assembles and then into rooms, and the ions in the seawater adhere to certain places on the inside of this polymer lattice work, and that a mineral grows. It self-assembles. It's outside of the critter's body. So what manufacturers would love to do is take something that we need to coat. And GM is actually doing this with their solar cars, with their plastic windshields. They're taking the plastic windshield, dipping it into a vat of organic molecules, proteins, that self-assemble onto the plastic, and then they dip it in another vat of ions, mineral ions. And the mineral ions self-assemble into a hard, transparent coating. Totally silent, energy-free. This is the paradigm flip I'm talking about. That's how nature makes things. But nature doesn't deal in things. I mean, nature deals in networks. That beautiful laminated shell of hard and soft and hard and soft is a network. You know, it's a structure that those two things by themselves aren't strong, but together they are. That's the deeper principle that we're just starting to learn. It's composites, bringing unlike things together, just like in this room, for the gifts that they have to bring, and the sum is stronger than the parts. It's amazing. And nature does this at all levels of scale. Think about the networks, the parts assembled in your tendon, okay, in your muscles. Your tendon it's like a rope. It's a twisted bundle of fibers, okay? That's what it looks like. And each one of those fibers is a twisted bundle of microfibers. And each one of those microfibers is a twisted bundle of proteins. And each one of those proteins is a twisted bundle of amino acids. And they self-assemble into a tendon that is able to do this. Pick things up, swing from vines, dance at the Union Club last night. structure granting function, right? It self-assembles. This network self-assembles. And then there are bigger networks, including the one in this room. Think about every breath you take. When we breathe in, we're breathing in what scientists are now calling aerial plankton. Have you heard this term, aerial plankton? We realize now that invisibly in the air, there's mites and I hate to do this to you. Here's what's happening in the air. Aerial plankton, mites and nematodes and bacteria, and some of them never come down. They're doing their own predator-prey thing. They've got their own networks going on in the air. Okay, amazing. We breathe that in, along with oxygen, and then we breathe out some of it, hopefully. And we breathe out carbon dioxide, right? And that carbon dioxide goes into a leaf. The leaf takes sunlight and water and my carbon dioxide. And if you follow that carbon molecule, as we've started to do in forests, you find something really amazing. It goes down from that leaf that I talked about, it goes down to that trunk, goes down into the roots, that carbon molecule, and it feeds some fungi that are down there in the roots. Those fungi, they're called mycorrhizae. They wrap around the roots, and they actually help the root get more water and more phosphorus and minerals that it can't get. And the tree gives the fungus in return, it's a nice business arrangement, carbon. Now here's what's really amazing. When I went to forestry school, we were taught that all the trees out there are competing for water and nutrients. And you've got to cut down certain trees because they're all competing. And what we're actually finding now when we label those carbon molecules that are coming in and we track them through the forest, we find that that carbon is being transferred from one tree through the mycorrhizae to another tree. The ones that are in the canopy that have a lot of sunlight, they have excess carbon. They allocate that resource to a tree that's shaded in the understory. Now you probably are saying to yourself, well, yeah, it's their it's their genes. It's trying to keep its own genes alive. It's a tree. It's young. It's not only not its young. It's not even the same species. Trees are passing with their fungal intermediaries, passing carbon around the whole forest, allocating resources around the whole forest. We don't know why this is happening. It looks like something is happening for the common good. You know? Anyway, it's a very, very different paradigm from our competition paradigm. And we're just beginning to understand the natural integrities of a system that is intact. And we have great need for this. Let me tell you another story from the book. It's a story about agriculture, and very often when I talk to business audiences, I can see them start to play with their PDAs, when I start to talk about agriculture. They're not interested in how we grow food because that's somebody else's job. And I say, no, wait a minute. It's becoming agriculture and forestry and fisheries are becoming extremely important for industry. And the reason is that we're beginning to go to bio-based industrial feedstocks. Instead of making carpets out of nylon, we're going to start making carpets out of cornstarch. So suddenly, a carpet manufacturer who wants to be sustainable, like Interface does, has to begin to go upstream and say, well, phew, I'm not taking oil out of the ground anymore to make this nylon carpet. However, how is that corn being grown? And how much oil is being used to grow that corn? And are we now starting to mine soil fertility instead of oil? We're really at a very delicate place right now because there's a land rush going on right now for bio-based materials. And everybody thinks it's a panacea. It's the time for us to say, let's make sure that corn is grown organically. So it's the time for us to look at a paradigm flip in agriculture. The way we do agriculture right now, the reason it's so oil intensive, is that we don't create a system that has natural integrities. Instead, we create a factory that we thought was very efficient. It was very efficient at extracting fertility, is what it was efficient at. What we do is we have an annual monoculture, okay? So it's annual plants, and it's one species for miles. And what happens when you have that is that you have to dig up the soil each year. And when you dig up the soil with biodiesel, or not biodiesel, regular fossil fuels, it's petroleum input. When you dig up the soil each year, you lose fertility in that soil. So you have to add fertilizers, which is a natural gas derivative. So you're adding petroleum there. And when you have one species for miles, a monoculture, which don't find often in nature, lastingly, when you have a monoculture, it's like an all-you-can-eat restaurant for pests. You know, a pest that gets the key to one of those plants and figures out how to crack it is able to just get going. That's how pest epidemics get going. So the biomimics in Kansas, Wes Jackson of the Land Institute, which you've heard Alan talk a little bit about last night, he said to himself the central question for a biomimic, which is, what would nature do here? If we weren't here, what would nature be doing? And what he found was that it's the tall grass prairie. That's what would be here. And he looked at the tall grass prairie, and oh my gosh, was it different than annual monoculture. It was different in about 180 degrees difference. And he said, can we remake farming in nature's image? And if we want to do that, if we want a productive system that doesn't bleed away soil, and that fertilizes itself, and that takes care of its own pest problems, we've got this great model here. So he began to study the prairie. And what he found was they went out for 7 years and they put down the grasses and they dried them and they put them into piles. What he found was that despite the fact that they had hundreds of species, in a room this size you'd maybe have 200 or 300 species of plants, that all of those species fit into 4 piles, just 4 piles. There was a deep pattern. This is what we're finding. There are these deep patterns that are telling us something about how to live on Earth without destroying it. 4 species: cool season grasses, warm season grasses, legumes, and composites. Legumes are the fertilizers. You know, they're the nitrogen fixers. So that's what gives the self-fertilization. So he said to himself, well, could we take our crop species fit into those 4 categories? Could we take our crop species and breed perennialism back into our annual plants? Big job. And then could we grow them together in a field? Harvest them at different times of year. And create a domestic prairie that we can eat food from, and that will also give us the structure of that prairie, all the different root zones, all the different layers of vertical layers and horizontal diversity. Can that structure, that community structure, grant us the function of both food, but also building soil as the prairie's done for 5,000 years? The question is, can we, with nature's help, create a community structure whose emergent property is sustainability rather than growth? And he just did it looking at agriculture. And it's not going to be the same everywhere. I mean, in Costa Rica, agriculture should look like a 3-tiered tropical forest. You know, the earth is not monolithic. It's made of little places, and the solutions are going to be local. But the solutions are out there if we're humble enough. So this idea of creating a community structure that grants the function of sustainability go all the way up to our whole economy, because that's the work we're in. That's really what's happening now. Right now, we have a community structure. We have a network out there that is rewarding certain kinds of behavior, which is growth, economic growth built on the back of the earth and the bowels of the earth, right? That's what we've got. And actually, if you look at the economy we have now, it looks a lot like a system that is in nature. What happened was in 1992 at Woods Hole, some business leaders invited some biologists to come and talk to them. I call it the Birkenstocks teach the suits. And these folks came and talked to them, these biologists who knew about prairies and knew about estuaries and coral reefs. And they listened, and they heard about our economy and heard about the manufacturing flows in some of these businesses. And they said, well, you know, you are imitating a natural system. You're imitating a type 1 system. And what a type 1 system is when say a farmer's field is dug up and left fallow. And what happens is annual weeds come in, right? And what they do, they have a strategy. They come in and they take all of the resources that they can and they put it into plant bodies, not very many roots, and they put it into seeds because they're going somewhere else. They have another place to go, another horn of plenty to go to. That's their strategy. It's a colonizing, pioneering type 1 system. And that's what we've been like. I mean, we've basically taken virgin raw materials, turned them into products and waste and people, and moved on and gone back and gotten more, instead of putting the roots down and doing the recycling that needs to be done. So the business people said, all right, tell us more. What should we be doing? And they said, well, you know, if you look at the way the earth is, and this is Herman Daly gives this simple description, but it's powerful. Actually, that type 1 system that we emulated, that was the most natural behavior in the world for us. Because what we did was, we were a small population of people in a world full of resources, right? Just like those weeds. And it made a whole lot of sense. We could keep going, you know, that was natural. But now we're a full population, we're a large population in a world that doesn't have many resources. Our root ball is up against the walls of our container at this point. And the conditions have changed. Winter's coming. We need a new strategy, right? We need a new strategy. So, here's what our economy should look like. And people in industrial ecology, the conferences that Alan and Paul and I go to, basically the premise is this, that I'm describing to you now. It's trying to remake the economy into this type 3 system. What a type 3 system is a mature forest. Okay? A type 2 is like the berry bushes, it's on the way. But the type 3 system is this mature forest. And what you have with a mature forest is a system that isn't going anywhere soon. You know, it's pulsing with life and it's dynamic, but it's pretty much staying itself there, in that place. So it learns to do something amazing. It learns to take very few material inputs, a whole lot of energy from the sun, and it learns to recycle what is there without putting out any waste at all. There is no concept of waste at all. And create more and more opportunities for life. As against that type 1 system, which is very simple, type 3 system has full employment. It's got at least 5 levels of recyclers, for instance. And every crumb that falls off the table is used before it ever hits the ground because it's seen as nourishment for another life form. You know? And so you don't have like one tree in a monoculture, and on that tree you don't have one bird, you have maybe 3 birds on that tree, all working that tree, one going down to find bugs, one going up to find bugs, one drilling in to find bugs. And on those birds, you've got 3 or 4 parasites and mites. And on those mites' eyelashes, you've got more and more opportunities for life. This is an amazing trick, right? More and more and more. And it's done through design and community structure. Believe me, all of these organisms are not doing it alone. What they can't do, they cooperate. They find partnerships to do more than they could alone. And again, that's the work that we're involved in. So it's really cool to think that all of this information that's been languishing in scientific journals, biological knowledge is doubling every 5 years. There are answers about how to live sustainably. Just in that, if we just were in that one forest for a while, and we really mapped out the metabolism of those material flows, the way the information feedbacks work, the way the cooperative networks work, and we really followed the metabolism, and then tried to match that onto our economy, we'd find lots of holes. We'd find that we take perfectly good products and we put them in a landfill because there's nobody to take them apart and use the parts. There's nobody at the design end building them to be taken apart. But that's changing. That's changing, and there's going to be all kinds of business opportunities to fill in the web, to fill in the niches. There's going to be people designing for disassembly, and there's going to be people disassembling. That's the way we're moving, and we have to. But there's lots more that's locked in biology right now. I mean, if there's one thing that you walk away from here with, it's ask yourselves whenever you're going to do something, how would nature do it here? And the other is hire biologists. Get them. They're driving taxis. They'll probably be driving you to the airport today. Hire these people. Hire these people, rent them, buy them a dinner, whatever you have to do, and start to have our designers and our biologists talk to each other, so that the metaphors begin to flow the right way from biology into design. That's what I'm really, really hoping, and I see it happening. So it makes me hopeful. I think the legacy of biomimicry is what I've been talking about a lot today is nature as model. But nature is also measure. In other words, nature can help us judge the rightness of our innovations, and mentor. I think the greatest legacy of biomimicry is not going to be a gadget. You know, spider silk flak jackets. That's not what it's going to be. I think it's going to be a whole new way of viewing and valuing nature, is what the legacy is going to be. Because when you begin to see nature not as a source, not as a warehouse, but as a teacher, things change. You know, Wes Jackson says the notion of, when gratitude tempers greed, the notion of resources becomes obscene. When you begin to learn, when you begin to say to nature, what would nature do here? And then you say, what wouldn't nature do here? And then you say, why and why not? You learn a whole lot of stuff. And you begin to see nature in a completely different way. And that's the most transformative part of this, I think. Because when you begin to then realize that the wellspring of good ideas is unencumbered evolution. And unencumbered evolution needs wild habitats. Here's my secret agenda. You know, and unencumbered evolution is way more precious than a vein of gold or oil will ever be. And so the gratitude turns into this ardent desire to protect the genius that surrounds us. And let's imagine what the world would be like if we did begin to look and function more like this world. What would it be like? You know, I think that separation of built world and natural world, that artificial separation, of course there's only one world, the natural world. We're in it. We are it. We're nature. The artificial boundaries will dissolve when we become functionally indistinguishable from the natural world. Our human-made world becomes functionally indistinguishable. And on that day, we'll be home. We'll finally be able to get comfortable in our skins and stay here at last and for good, on this home that is ours but not ours alone. I honestly believe that Earth gave rise to that sandhill crane and to humans. One that can fly 2/3 of a mile up and make beautiful music on lizard fuel. And one that can track that flight and wonder about it. And if we want, even imitate it, even mimic it. Earth gave rise to cranes and to humans. And my hope is that one will learn from the other, and that both will be around for a very, very long time. Thank you. Flockmates. Yes.
How do you take these ideas? I think your ideas are brilliant, but I sort of wonder what it would be like sitting in Mark Roscoe's economic development thing when we're talking about bringing in big hog farms to build the agricultural economic development. How do you, people like that glaze over? Do they understand this? Or how do we get people to, to me it seems like we have to get people to open their imagination and their minds. What industry, have you seen this happen?
It's amazing. I think a lot of things are coming together right now that make people like Wes Jackson, who was praying in the wilderness for years, all of a sudden, people are listening to his ideas, and they're doing perennial wheat research at WSU. Things are changing, and a couple of things are happening. Look at what happened with genetically modified foods. Overnight, something that was, we can't do anything about this, became Monsanto's worst nightmare. Monsanto tanked. And it was because people said, no, this is too scary. That was those sorts of tipping points, that's very exciting. The other thing is this whole climate change stuff that's going on. What's happening is that companies are gearing up to do carbon sequestration, okay? If they're emitting a bunch of carbon dioxide, they are going to have to, in the future, they're going to start trading credits of carbon, and they're going to have to find a way to sequester their carbon. So all of a sudden, really, agriculture is going to be very, very important. Places like Montana and Canada that have large tracts of land that do grow crops and forestry are going to be very, very important. What we need to do right now is get in here at this time and say, okay, you're coming to us for industrial feedstocks now, and you're coming to us for carbon sequestration now. Now, take the money that you have, the profits that you're making, and help us to do this sustainably. Instead of a monoculture, help us to do a polyculture. Instead of forest plantations, help us to do natural forests that will sequester carbon. There's going to be money available, I think. And this stuff is not as wild as it was even 2 years ago. And a lot of it is because of the pressure from the pressure groups, thank God, that are working, that are bloodying their noses on that. And the fact that there's policies, government, the habitat is starting to look more like type 3. The regulatory frameworks are starting to encourage type 3 behavior and to punish type 1 behavior. Some of these policies are coming online, like Kyoto, the climate change protocol, that is now having everybody scramble to find out where they're going to put their CO2. And companies that are out front, like an interface, the pseudopod of the amoeba, that's already trying some of this stuff and practicing these moves for the time when everybody will have to do it, they see that they're going to have a comparative advantage. But what they're scared of, and what people in this, what other companies who are trying to do sustainability are frightened of, is that in this system, this economic system that still encourages type 1 behavior, places like interface might not do well economically. What if they don't? What if that species goes extinct before the adaptations that they are learning get to be spread, okay, in the gene pool, in the meme pool? Now, here's what's happening, and it's a flocking up. Last few meetings in the last few weeks that I've gone to, there would be a group of 20 people. Each person would represent a company that was trying to get into sustainability. Ray Anderson of Interface mentioned his leasing program, the carpet leasing program, okay? They sell carpet tiles. They do it in their modular carpets, they're in tiles. And instead of selling you a product, they sell you a floor covering service, because they assume that you don't want to own 20,000 pounds of nylon. But they want to make sure that they get to service your carpet. They go in and they maintain your carpet for 5 years. And when your carpet wears, they pull up, not the whole thing, but just the tiles, and they take those tiles back and they recycle them into new carpet. Okay, so it's a whole new way to think. The manufacturer becomes responsible for the product, okay? And so they're very much responsible in making a product that is easily zippered, you know, taken apart so it can be recycled. It's a wonderful concept. Problem is that he can't sell any leases. Interface is not selling many leases. The reason is that the purchasing people it's a human thing, the purchasing people don't know how to treat this. They're used to seeing carpet as a capital asset, you know? They don't know how to treat a lease, so they don't want to deal with it. So in this meeting of all these companies heard that and said, okay, we're going to go back to our Harley Davidson, Ford, wherever they're working, GM, not GM, but Shell, wherever they're working. We're going to go back, and we commit to, in a year's time, we're going to turn our purchasing people around and find the financial thing that needs to happen in order to get our carpets be interface leasing, okay? Now you might say to yourself, wow, good for Ray Anderson, he was there selling. He wasn't. That's what I'm saying to you. These companies realize that if Ray succeeds, they succeed. So they're flocking up because they found a good idea, because they notice a good idea, and they're going to support it. Government was there. What if the government starts trying to do carpet leasing? My gosh. I mean, so this is the lever point we're at, Bryony. That's what I'm saying. I'm feeling like instead of just picking away, you know, with a pick and shovel, it's like whole things are changing. Whole landscapes are starting to... The fitness landscape is changing. The environment is changing. So those who are most adapted, you know, the idea of what works is changing. Crazy people like Wes Jackson all of a sudden look pretty darn smart and fundable.
Janine, will you give us your take on the energy side of things? Because the same reality gap exists. You were describing structures and networks of materials, but in a way that's the same thing as saying structures and systems of energy. Respiration and the carbon and oxygen cycles have to do with energy on a deeper level. And then on the other hand, you've got mankind is doing just as badly with energy as you were describing when you were doing with materials.
Yeah, we're using a lot of energy, and but most importantly, we're using the wrong kind of energy. And by wrong, I'm going back to, is it well adapted? When I look at life, I see that life basically goes to one energy source and one energy source alone, and that's current sunlight. And we've gone to ancient sunlight, which is, you know, the dinosaurs and plant remains that we're now digging up and burning in this giant bonfire. Life has figured out how to go to current sunlight. And again, this is shifting. You know, BP has the new advertising campaign out that says beyond petroleum or burning the planet, whichever side. I mean, they need as much having their toes held to their fire as if they do have a good idea, let's nurture it. Both needs to happen. But the energy side of things, I think, is at the same time as companies are lobbying Congress to keep those oil subsidies coming, those same oil companies are beefing up their R&D in solar and in the hydrogen economy. They seem to be going towards the hydrogen economy, meaning using hydrogen in fuel cells. And the hydrogen in fuel cells, the hydrogen comes from splitting water, cracking water, and then you use that hydrogen in a fuel cell, and the byproduct is water. Here's where the delicate thing comes. We have to pressure folks to get the hydrogen. What they're saying now is, well, we'll get the hydrogen from natural gas. Let's not get stuck on that suboptimal peak. Let's push for solar hydrogen. Let's push for going to the sun to crack water to get a storable fuel.
Since you're on a roll, we've dealt with matter. Could you comment a little bit on air and water?
Air and water.
In the same perspective.
I can comment on water. A biomimic looking at how does nature filter water? What nature does is use plants and microbes and organisms in marshes to filter water. When you go to our sewage plants right now, you would not let your kids play there. I mean, they are sterile. There's like barbed wire to our sewage plants, right? And yet, the marsh next door is filtering the water better, and it's also doing that multifunctional thing. So birds are flying in, and it's creating more conditions conducive to life and more opportunities for life. So what people are doing is doing constructed wetlands in which they're trying to imitate that ecosystem in order to filter water. And even inside, they're doing what's called living machines, which are tanks of plants to filter water.
Getting late,
Yeah.
we'll just do one more question.
I wonder about, you could comment on the fact that people are maybe becoming aware of the greater bubble, but still, since it seems to be only in, I would say, slow gradation, for instance, even in this environmental conference, we still use a lot of paper, a lot of glass, a lot of waste. You know, at what point is this going to, evolve into, your dream, your vision?
I think, I don't think the conditions are right for the saving of resources to be the most natural behavior. I mean, I think it has to get to the point, really, I think that we are an adaptive species, and I think we would begin to save paper, and we would begin to think more about our actions if the price signals were right, the habitat conditions. In other words, if doing something was expensive, we wouldn't do it. We would find another way to do it. By allowing price signals to be the way they are, to externalize the costs, we allow ourselves to languish in this denial. And we also take away the motivations to really act in a more natural way and to come up with the innovations that we need to be that type 3 system. Somehow those price signals have got to shift. And that's one of and regulatory and mindsets and heart changes. Because people like Ray Anderson got hooked into this not just because it was going to make money, but because he has 7 grandchildren, and the spear went through his chest. And he's doing it from the heart as well. So all of those things have to change before we become mindful of what we do.
Thanks, Janine.
You bet.